So example 18 is asking us to find the modulus and argument of the complex number -2 minus I. So the modulus R is equal to the square root of -2, the real part square, plus -1, the imaginary part square. So this is the square root of 5. Now the argument of Z theta is equal to minus pi plus tan inverse -2 divided by -1. All right. So in your calculator, you're going to put, you're going to first press minus, then shift, then exp. That which is the second function of the exp button. Exp button is pi plus
Sir, you
shift
have
again.
x over y.
I have x over y. Okay, thank you. What is the imaginary part first? -1, -2. Ooh, you know that, but this look like it's a half. No, well, no, there's no special nothing for tan inverse a half. All right, so there's no special angle for tan inverse a half. So it's all right, so I have to do it over. So it is minus, then shift, then the exp, then plus, shift again, tan, open bracket, imaginary part first, which is -1, divide by the real part, which is -2, close bracket, equal, and I'm getting that the argument is -2.678, and this is to 3 significant figure.
Sorry, go again, because mine saying syntax error.
You're going to press shift. Sorry, before I press shift, press minus.
Sir, I make sure that it's in radius, right? So I
Must be in radians.
right. Okay, it have the small r.
Yes.
Okay.
So it's minus,
Mm-hmm.
then shift.
Yes, sir.
The exp, that will give you pi. You should see pi on the calculator screen.
Okay.
Plus, shift
Mhm.
again, tan, open bracket, -1, which is the imaginary part of the complex number, divide by
Divide.
-2.
Oh, sir, so don't use the over sign.
I don't know if it'll give you a problem, just use the divide.
Okay.
Then close bracket, then press equal.
Sir, still saying syntax error.
All right, mine gave me the answer. All right, but
Sir,
for some reason I got a different answer now.
Sir, I got -2.03.
Yeah, that's me too. -2.356. That's what I got. Anybody get this?
Sir, I'm going to do it over again.
And this is the 3 decimal places. To 3 dp. Anybody else?
Okay, sir. So you said I'm supposed to. It's in radians already. No. I'm supposed
Minus.
to minus shift.
Then press the exp to give you pi.
Okay.
You should put pi on the calculator.
Yeah, I see the. Wait, no, I see E. Sorry, I need to get that calculator because
So now I get -2.6768.
Okay.
I don't know.
The answer, what is it? The answer, what? The answer changing? This is weird. This is minus shift, then pi plus shift tan, open bracket, -1 divide by -2, close bracket, equal. All right. I'm getting the same thing again. So what you got, what we got the first time is what I'm getting again. And this is 6, 7, 8. And this is 2, 3 decimal places.
That's what I just got.
Yeah, man. Lindsay, I'm muting you. All right, guys, I want to move on. Now this says trigonometric or polar form of a complex number. And essentially from here, if z, that the complex number z is equal to x plus iy, that is called a Cartesian format, is the same as is equal to r open bracket cosine theta plus I sine theta. So r open bracket cos theta plus I sine theta close bracket is what you call the trigonometric or polar form of the complex number. So here I'm reminding myself that I need to show you how. Using this, the side y is opposite to the angle theta and x is adjacent. So the sine r is the modulus, which is the length of the complex number or the length of the vector representing the complex number. So the sine, sorry, first cosine, the cosine of theta, cosine is what? Adjacent over hypotenuse. So it's adjacent x over hypotenuse r. Now, if I have one fraction is equal to one fraction, to get rid of the fractions, I can cross multiply. So x is equal to r multiplied by the cosine of theta. The sine of theta is equal to opposite y over hypotenuse r. If I have one fraction is equal to one fraction, to get rid of the fraction, I would cross multiply. 1 times y is equal to r times the sine of theta. So the complex number z, which is x plus iy, may be written as x, which is r cos theta, plus I times r sine theta. All right, which is y. R is common, so I take out the r is equal to r cos theta plus I sine theta. Now, z is equal to r cos theta plus I sine theta, or z is equal to r into cos theta plus I sine theta, is the polar form or the trigonometric form of the complex number. Do you understand?
Please repeat.
Which part of it?
Sir, the part you're explaining of it being equal to the other.
Remember, no, we just showed that x is equal to r cos theta, and we showed that y is equal to r sine theta from this calculation up here. So z, which is what, x plus iy, can be written as x, which is what, r cos theta, plus I, y, which is what, r sine theta. Then I said that r is common, so I factor out the r. And so z, which is equal to x plus I sine theta, is equal to r into cos theta plus I sine theta, where r is the modulus of the complex number and theta is the argument of the complex number.
Yes, sir.
All right. So let me stop this video and then ask you guys to have a look at example 19.